Welcome back to Natalia's classroom. Hope you are learning time series analysis in Python with me. Please like, share, and subscribe if you want to learn in an easy way. In the last two videos, we have learned the first two steps of time series analysis. I'm giving the links in the description box in case you have missed the step number 1 and step number 2. Step number 3 is to make the non-stationary data stationary because Python's ARIMA model works with stationary data. I have shared details about it in step number 1 video. So as in step 2, the Dickey-Fuller test has shown that data is non-stationary. So let us learn how to make it stationary. Okay, so there are many different ways to make data stationary for ARIMA model. Sometimes we take log, sometimes we apply some other formula. The easiest way or the simple way is to take the difference of the series, where we will shift it one step down, or we will implement one time lag. So okay, we imported this .csv file, and we created a plot, and the plot has shown us that the data is not stationary, and then we applied the Dickey-Fuller augmented Dickey-Fuller test, and it also resulted in the it also showed us the result that the data is not stationary. So now the objective is to make data stationary so that we can use it in ARIMA model. So these are very simple steps to follow. Let us first check the data values. Smartphone is our data set. So smartphone dot head, and it will show us the data values. These are the data values, and we want to make it stationary. So for this, let us use the method of one time lag, one step difference that we create to make the data stationary. Smartphone underscore stationary is equal to smartphone dot diff periods is equal to 1. So what does this function do? It actually creates one time lag in the time series and makes it stationary. So this is actually the one of the parameters that we pass to ARIMA model in our next steps, and it is also called the D parameter. So this is the I in ARIMA model value for integrated, and it is represented with D. So it is represented with parameter D in ARIMA model. In next steps, we will use this parameter when we will do the analysis. So first of all, we are trying to make our data stationary, and for this I have used the diff function, and I have set the periods to 1. So now let us see how does it look like. Smartphone underscore st dot head. So the first value is nan, because it is shifting the values one step down. So the first value is nan. So we can drop nan, or we can make a new set excluding nan. So let's make a new set. This nan parameter by just using the drop nan function, or by just taking the values from starting from index 1 onwards. So let's do this. Smartphone underscore st is equal to smartphone underscore st 1 colon. So it will ignore the value, or it will eliminate the value, remove the value from the data set, and it will take the values from 1 till the end. So let us check our data set now. So see, it has ignored the value, nan value has been dropped now, and we have our stationary data set. Let us plot it. Now it looks somewhat stationary. So this is how we can easily make our non-stationary data set stationary with the help of difference function, or using the integrated or D parameter for ARIMA model. It, till the next step, you can do some practice on some data set, and in the next step I will implement ARIMA model on the stationary data I have in my smartphone underscore st.